I'm standing in front of Labtech's latest multi-layer blown foam line. This line can run 5-layer foam, and it can be modified to make 9-layer foam using 9 extruders, and then it can be used for making 11-layer blown foam using 11 extruders. Now this line is on 2 levels with steps leading up to the platform on top. And this design of the line is very useful. Here we have a small platform which has been manufactured and placed next to the die and air ring. And it's very convenient for the operators to clean the die lips in the die and to string up the line, and also for adjusting the air gap for the air ring. So let's have a look at the details of the blown foam line. First of all, we start with the extruders. Now the extruders, 5 of them in this case, are arranged around the die, evenly spaced. And each extruder has a loss in weight feeder here. Now these are essential to make very accurate multi-layer foam. The loss in weight feeder will give a very constant feed rate of material into the die, and therefore it will give a very accurate layer thickness. Now these are automatically fed from the hopper, so that when the level goes down, when it gets to a certain level, the gate here will operate and it'll admit more pellets into this hopper here. These are quite small extruders because it's a laboratory multi-layer blown foam line. These extruders are 25 millimeter and 30 millimeter in diameter. And each of the extruders is fitted with a pressure control valve to monitor the melt pressure at the end of the extruder. So over here we have the die. This in fact is a 9-layer die, but the bottom 4 layers are being blocked off so that we're just running 5-layer blown foam now. This is the pancake die, and the melt flows through the different layers. Each extruder is dedicated to feed material into a particular layer. And here we have the air ring for cooling the bubble. You can see this is a dual lip air ring where we have 2 air gaps for cooling the ring, one lower down and the other one higher up for the outside. And the air ring, the chamber here, is fitted with a temperature control, well, a temperature monitor, temperature gauge, and also a air pressure gauge. These are the pipes leading we have chilled air from a chiller unit over there. So these are all fed from the distributor box down here, all around the air ring, so that we get very even cooling air coming out of here to very uniformly cool the bubble. So as the bubble is passing up the tower, we stabilize it using these curved guide rollers made from PTFE so that we have no sticking. These can be adjusted, the position of the rings can be adjusted using this knob here. And we also have some sensors three of them located around this ring. There's one here, and there's one there, one here. Yeah. And these are monitoring the diameter of the bubble so that we can set the diameter. In fact, we set the lay flat width on the control panel, and this is calculated to give a certain diameter bubble. And if the bubble tries to get too big, then the controller will allow air to be removed from the bubble to make the bubble smaller diameter to come back to the set value. And likewise, if the bubble becomes too narrow, it'll introduce air so that the bubble will again inflate and get back to the set value. So this is the tower. We can go up the steps onto the next level now to see the bubble being flattened at the top before it goes through the nip rolls. So let's proceed to the next level. So why do we need the oscillating nip rolls units at all? Well, if we don't have a oscillating nip unit, or we don't use it, then whenever you make blown foam, there's always a very small variation in the thickness of the foam in various places. Maybe 1 or 2 microns difference in thickness. Now, if you don't use an oscillating nip gap unit, those thicker parts of the foam will get wound up in the same place on the wind-up bobbin. And as the bobbin gets bigger, this thickness will accumulate, so that in the end you'll have a roll of foam which is got bumps on the roll, which are, when you unwind that foam from the roll, those parts would be stretched. And this is a problem for later operations like printing, cutting, adhesion, or whatever. So when we use the oscillating nip gap rotating unit, what happens is that those slightly thicker parts of the foam slowly get moved from one side of the lay flat foam to the other, and then back again. So those thicker parts will not be wound up at the same place on the wind-up bobbin. They get moved along from side to side, which results in a roll of foam which is perfectly flat and smooth. So this is rotating 360 degrees in one direction slowly, and then after 360 degrees it will rotate back again to the same position and back again, and so forth, back and forth and back and forth. And so that has the effect of spreading out, distributing these thick sections across the roll of the foam. So that's a function of the oscillating nip gaps haul-up unit. And this is the way we put in the edge slitters in the foam. First, slit the foam. And just slide it in. And the other side, slit the foam, open the two sides, slide in the edge slitter. There we are. outside slit, so we can wind up individual layers now on the bobbins. Make sure that there's no gap there. Good contact. There we are. 2 single layer films. In this case, 2 films, each 5 layers.